Okay, in the first videos of this playlist, I talked about the reasons of why we need to factor polynomials, and I said we need to do this by for solving equations or inequations, but there are problems in which asks for factoring polynomials which contain more than one variable. In the sense, polynomials like this: plus z squared minus 3xyz. And why we need to factor such a polynomial? For instance, we need to factor this for solving this equation. Okay, but what kind of an equation is this? Let me give you a simpler polynomial like x minus y, or a simpler equation containing more than one variable. And what kind of equation is this? And in the first videos of this playlist, I gave you examples of solving equations, which mostly were geometrical examples in which we needed to find some distance or the length of something. But here, for instance, 1 minus 1 would be a solution to 1 and 1 would be a solution. 2 and 2, which is 0, 2 minus 2 is 0, and 10 to the power of 10 minus 10 to the power of 10 is also a solution. But why do we need to solve such equations? I know one thing in which we need to solve them. But before, I'd like to talk about another thing. And in engineering, in branches of engineering, in physics, in chemistry, in economics, we like to visualize things. For instance, this is some polynomial, say x squared, a simple polynomial, or this is a monomial, say plus 1. Okay, how could we visualize this? And And this in practice, in the branches of science I mentioned, x and y would represent something. For instance, in physics, x may represent, say, something like energy, and y would represent another thing, in which such a relation exists between them, and we like to visualize it. And let me not talk about how to visualize this, because it is for the later grades. We visualize this like this. Okay, this is a parabola, the red curve. This is x-axis we call, and this is y-axis. And x is this is a plane, and x for every point on this plane. So let's say this point, x is the horizontal distance from the y-axis. This is x, and y is the vertical distance from the x-axis. This is y. Okay, and for the points on the red curve, between their x's and their y's, such a relation exists. Okay, and why we like to visualize, because this way we could see what is happening. For instance, we had some curves like this, and we could see that, for instance, as the values of x increase, and this way the values of x increasing, and this way the values of y increasing. Okay, and and for such a curve, we could see as the values of x increasing this way, the corresponding values of y also increasing from here to here. Okay, for instance, as the values of x increasing to this point, this point and this, their corresponding value or their corresponding y's also increasing. For instance, the point corresponding to this x on the curve is this, and its y is this, from here to here, this sense. Okay, as the values of x increasing, the value of y also increasing to this point. But then the values of y, as the values of x increasing, or as we going to the right, but then the values of y starting to drop till this point, then increase to this point, And we could analyze easily such information. Okay,